So if we have a physical quantity, it should have a numerical magnitude and the unit. So if we have a numerical magnitude and a unit, what we call that as a physical quantity. The physical quantities are divided into two main categories. The first one is refers to, these are the learning objective of the syllabus. This one is for Cambridge as well as for edXL. It's a combined one. So the physical quantities or the measurable quantities should have a magnitude as well as the unit. So, and these physical quantities are divided into two categories. One is known as the base quantity, or also known as the fundamental quantity. There are 7 fundamental quantities which you have to learn. The first one, the mass, it's a fundamental or a base quantity. The time, it's also a fundamental or a base. Length, electric current, temperature, amount of the substance, and the light intensity. What are the units of these fundamental quantities? These units are also known as the base units. So if you have a basic or a base quantity, there will be a base unit. So what is the base unit of the mass? The base unit of the mass is kilogram. The base unit of the time is second. The base unit of the length is meter. Other units are there. Kilometer, millimeter, centimeter are other units, but the base unit is the meter. Electric current, ampere, temperature, Kelvin, other units are there, Fahrenheit, centigrade or Celsius. Amount of the substance, mole, and the light intensity or the luminous intensity, that unit is candela. Instead of writing them all like writing kilogram, second, we can use the symbol. So if we want to mention a kilogram, so we use the symbol kg. For seconds, S. For meter, M. Ampere, A. Kelvin, K, capital K. Mole, it's MOL. And candela is CD. But in physics, the last two quantities, you will not use them at all. So mainly what we'll use the 5 main fundamental quantities. So these are the base quantities or the fundamental quantities with their base units. Any quantity other than these 7 are refers to the derived quantities. So a quantity other than these 7, we call that as a derived quantity. Like example, if I mention force, so if I mention force, so we don't find the force. Force is a physical quantity, but we don't find force in the base quantity. So what we call, if it's not a base quantity, then we call that as a derived quantity. Same thing, if I refer density, you don't find density in this column. So what is a density? Density is a derived quantity. If we mention a pressure, you don't find a pressure here in the base quantity. So pressure is the derived quantity. Now we can relate the base quantities and the derived quantities by the unit, and these units are known as the base units. So the unit which relate the derived quantities and the base quantities, we call that as the base units. Example, say if you want to write the base unit of force. So we want to write the base unit of the force. What are the base units? The base units are like we have to express either in kg or meter or second, ampere, Kelvin, mole, or candela. If we represent any quantity, the unit of the quantity in any of them, we call that as a base unit. So how to write a base unit, how we can... So first, what is the unit of the force? What is the unit of the force? Yes. What's the unit of the force?
Newton.
Yes, Hafsa.
Newton.
Yeah. So the unit of the force is Newton. But is this Newton is a base unit? No.
No, sir.
Why it's not the base unit? Because the base units are only 7 are there, which is kilogram, meter, second, ampere, Kelvin, mole, and candela. These are the base units. Rest all of them are the derived units. So Newton is not the base unit. Newton is a derived unit. So how to convert a Newton, or how to write a base unit of the force? So first thing, we have to write a formula for that physical quantity. You can write any formula related to that quantity, it will give the same result. Example, if I remember the formula of the force, I can say that force equals mass multiplied by acceleration. Or I can say F equals ma. You can use any formula, so but I remember example F equals ma, force equal mass into acceleration. So how to write the base unit? We will write the unit for each quantity separately. What is the unit of the mass? What is the SI unit of the mass?
Kilogram.
Kilogram, kg. So SI unit of the mass is kg, so we represent m in kg. What is the unit of acceleration?
Meter per second square.
Meter per second square. So I can write meter per second square. That's a unit of acceleration. So if I simplify this, it will be kilogram meter per second square. And whenever we express the base units, we write them, all of them in numerator. So if I move the second square from denominator to the numerator, it will turn out to be kilogram meter second minus 2. So this kilogram meter second minus 2, this is the base unit of force. So what is the base unit of the force? The derived unit is Newton, but the base unit is kilogram meter second minus 2. Is it clear, this one? Anyone having a doubt or a question? Should I repeat? Yes.
Yes, sir. Clear.
What about others? No.
Yes, any doubt, Asher, Fabia, Shahir? Feel free to ask your doubts if you have any question or a doubt you want me to repeat. So I'll repeat that part as well. So this is the base unit. So we can also say the Newton is equals to kilogram meter second minus 2. So in exam, if they like usually in multiple choice question, they give you different options and they ask the base unit of the force. So you will not write as a Newton because Newton is not the base unit. Newton is a derived unit. The base unit is kilogram meter second raised to power minus 2. You can take a screenshot and later on you can make the notes. But I will also share the presentation with you, the part which we'll complete today. I will share that as well. So you can convert that into a PDF and prepare the notes. But the additional thing, what I'm writing during a session, try to copy those additional things. The reason is that because in the presentation, only topic and the definitions are there and rest explanation. I will use the white screen to explain the topics in detail. So what I'm writing, better you copy that as well. Another example, if I say, write the base unit of so if you want to write the base unit of energy or work, you can also say work done or energy. What is the first thing we do? Whenever you want to write a base unit, try to write a formula first. What is the formula you remember which you use to calculate the work? Any formula? which we can use to calculate the work?
Force times distance.
Good. So what is work? Work is force times the distance. And what is the unit of the work? We use joule, or we also use Newton meter, but these are not the base unit, these are the derived unit. So how to write? What is the unit of the force? The unit of the force is Newton. And what is the unit of the distance? The unit of the distance is meter. But Newton is not a base unit, Newton is a derived unit. What Newton is equivalent to, we just did that in the last example, that the Newton is equals to kilogram meter second raised to power minus 2. So Newton is actually kilogram meter second raised to power minus 2. So in place of Newton, I can write kilogram meter second raised to power minus 2. And this is already a SI base unit meter. So when we simplify this, it will turn out to be kilogram meter square second minus 2. So kilogram meter square second minus 2, it's actually a base unit of work. Or you can also say it's a base unit of energy, because whenever there's a work done, it either stored as energy or it transferred. So the unit of the work and the energy are same, which is equals to joules. So joules actually equivalent to kilogram meter square second raised to power minus 2. Is it clear, this one?
Yes.
Yes.
Now let's do some more examples, and this time you have to solve and mention your answers in a chat. So if you don't understand anything, you can just let me know. I will explain that. If any example you find it difficult. So first thing, I want you to write the base unit. Let's start with the simple one, density. Write the base unit of the density. First thing, the steps which you will follow, you will write a formula. The second thing, you will write the unit and express them in numerator. So density is mass over volume. That's a formula, but we need the base unit. What is the base unit of the density? Whenever you express the base units, it should always be numerator, like all should be there in numerator. The SI unit of the volume is meter cube. So base units, like you cannot mention centimeter cube as it's not the base. So first thing we'll write, whenever you're solving a question related to the base unit, first you will write the formula, that is density equal mass divided by volume. So first we wrote the formula. And then we write the units. The unit of the mass is kg and the unit of the volume is meter cube. The SI unit, we use the SI units. And when we move this in numerator, it will turn out to be kilogram meter raised to power minus 3. Then another, what is the base unit for pressure? The base unit for the pressure. The base unit for pressure. First, you have to write a formula that pressure is force over area. That's good, Asha. The SI, we always use the SI unit, so it should be a meter square, not centimeter square. Newton per meter square is the derived unit. So if you want to find, first we write a formula. The formula for the pressure is force acting on unit area. So force divided by area. Then we write the unit. The unit of the force is newtons. And the unit of the area is meter square. So Newton per meter square. But Newton per meter square, the Newton per meter square, Newton itself is equals to kilogram meter second minus 2. That's the, because the Newton, the base unit, that is kilogram meter second minus 2. And divided by meter square. So if we simplify this, as you can see here, this square can cancel with meter. So what we are left with? We are left with kilogram second minus 2 divided by meter. If I move this in numerator, it will turn out to be kilogram meter minus 1 and second minus 2. So normally the rule is like when we write the power in order, like minus 1 is greater than minus 2. So it's always in a descending order. Like this power is 1, then this power is minus 1, and this power is minus 2. So when we write the base unit, the order is always in a descending order. Is it clear? This example about the base unit of pressure. Anyone having a doubt or a question? Shahir, from your side, you did not send anything till now. Anyone having a doubt or a question till this point?